Hello, everyone, and welcome. My name is Georgi, and today with Rado, we will try to show you how you can get rid of your application secrets and make yourself proud to friends and family, especially if they're in IT. For the purposes of that, we will use the following agenda. We will start by defining the secret zero problem. Then we will go over a plausible solution in the face of SPIFFE and SPIRE. And last but not least, Rado will give us a practical example of how this technology can be put into practice in the real-world scenario. Or in other words, what we are trying to do today is to show how you can actually delegate the responsibilities of your applications, services, and systems of having to deal with the complexity of managing secrets, sensitive data like usernames, passwords, cryptographic keys, and everything else. OK, let's get going. Let's start with the problem definition. For the purposes of that, I will have to return you some good 10, 15 years back in time when I started my career in IT. Back in the days, we used to have a few servers under our responsibilities. They were safely communicating over HTTP without any sort of authentication. They were using and sharing a private network. And basically, they were happily delivering the end-user functionality to our users. We just tend to open a few ports to the outside world in case some access was needed. And then we tend to take care protecting it with certain means. At the end of the day, those servers were sitting just behind my back, and I can physically ensure their security and can physically ensure that they are running within this perimeter and no one is stealing data from them. Fast forward today, the situation has drastically changed. Nowadays, our applications are running against or on different heterogeneous environments, like my database is located and is using the best of breed persistency layer from AWS. My PubSub is from GCP because they are offering the most cost-effective solution to get the job done. We have a number of additional clients nowadays, IoT applications, as we heard on different presentations, mobile devices. We can't anymore trust this mess, basically. We can't be sure that the server that is communicating with my application is the one that it says it is. Nowadays, it's hard to throw these boundaries and to draw this perimeter around our applications because they are spread and there are different microservices and systems running all around the place. OK, and so far, so good. We have this problem. What is the most common solution that we see today to actually securely introduce one system to the other? Well, the most common solution to these problems are the so-called secrets. Basically, these are usernames, password, credentials, service accounts, you name it. You know, all sort of sensitive information that is pre-shared with a certain system and that this system can use to actually prove to another system that it is the one that it says it is. What is a challenge with those secrets? Well, basically, first of all, we invent them and we create them to enable certain access control. The same way like I have a username and password and I use it to authenticate to some provider. OK, we created this secret. However, since I mentioned it's a sensitive information, we want to protect it. So the next thing that we do, we invent some form of encryption and we encrypt this secret to protect it because it's sensitive. I can't hold it in my source code repository or directly baked into my container image. And then fundamentally what I do is I create another secret, which is the decryption key used to actually decrypt the very original secret that I wanted to create. OK, what I do with this decryption key, because basically it's also very important. Well, I store it somewhere securely, like, for example, in the HashiCorp Vault as a secrets repository. But then what I need to do is actually own yet another secret to be able to get and retrieve the very first one that I had to use, or de facto the decryption key of the very first one. And I think you follow the pattern. Basically, it's turtles all the way down. what we do is we invent secrets to actually protect the very first secret that our application needed. Okay, that's good, or that's what we can see today, but this is not the only burden and challenge that we need to face. There are multiple questions that we need to answer. Even if we invent this secret, basically we need to securely distribute it to our applications and our environments. We also need to rotate that secret. Also, I don't have to wake up half of my team in case we suspect some security breach and we need to rotate this precious credential 0. And technically, or ideally, the rotation should not involve human interaction, and also it should not cause downtime, because I don't want to make my users frustrated just because behind the scenes I'm rotating some technical information or technical data which is necessary for our service to operate. And even if I decide to trust and to put my trust in a container orchestration platform like Kubernetes, and I basically trust the resources which are called secrets there, that doesn't actually mean that they are treated as sensitive information. They are just yet another byte array which is distributed over the network and stored somewhere in plain text in some file and in some storage, which easily can be obtained by someone either intentionally or unintentionally. Okay, so far so good. We defined the problem. What is a solution to this problem? Well, the Cloud Native Foundation, the Cloud Native Computing Foundation, the same foundation that hosts Kubernetes, has 2 projects which exactly aim to solve this challenge. The first project is called SPIFFE. This is the specification. The second project, the reference implementation, is called SPIRE, and SPIRE tries to put the concepts and the documentation in an actual running software that you can place in your environment, and you can leverage the benefits from SPIFFE. Okay, now we'll go a little bit more over the theory behind SPIFFE and SPIRE and how they solve this challenge, so we later can follow the example from Rado with better understanding. I'll start with the definition, and if we have to describe it with 1 sentence, that would be it. Basically, SPIFFE gives us a way and gives us short-lived identity documents, and it does that via a simple API. Let's try to depict and break apart this sentence so you understand what we mean by it. The first keyword of this sentence are the so-called identity documents. And if we draw the parallel with the physical world that we live, basically you can see that in the real world I have my passport. I use it to travel, to go to the bank, and do some things. And then the authorities can know that, yes, this is the passport belonging to Georgi. SPIFFE tries to define a digital passport for our systems. You can see it like that in a simplified manner. The second keyword and the example that you can see here, SPIFFE doesn't try to reinvent the wheel. As we saw already in the talk from Stefan, basically JWT or JOT tokens are one format that SPIFFE supports, so they don't try to come up with their own thing. They try to trust on industry standards for cryptography. The second standard that you can see here, an example, probably for some of the security folks, is kind of popular, the X509 certificates. And what you can see in the certificate itself, you can see the validity. Like also we mentioned that if we reduce the time that the identity document is valid, we thus decrease the attack surface and the attack vector that potentially someone running away with that certificate will have access to our system for 10 years or so. And the last but not least, which is another concept from SPIFFE, is the so-called SPIFFE ID, which is a string, a simple identifier that actually baked into the certificate can be used from authorization systems and can be used to apply a certain access control policies as after the system is being authenticated. Okay, the last concept from SPIFFE the simple API from this single sentence definition. This, in SPIFFE terms, is called workload or workload API. I will use today the terms application, service, and to a certain degree system interchangeably, and they all can map also to a workload. The workload is the process that actually needs this precious credential 0. You can see it as my business application or as my layer that needs to communicate with the database. Basically, the workload has one responsibility. It starts and it asks the workload API, hey, workload API, give me my credential. That, important to mention, happens without the pre-shared secret. So we break this vicious cycle of secrets all the way down. And basically, this workload API can solve us this problem. And here you can see the two formats that can be returned to the workload. Today, we'll use the X509 certificate as during the next examples, but easily can be, it's abstracted in such a way that JWT tokens can also be leveraged. Okay, now we have the theory in practice. Let's see the environment and let's see the software that actually implements this specification. And here we will start from the bottom up. So we will start from the perspective of the workload, which is the user of this whole SPIFFE and SPIRE magic. This is our application, service, process, So the workload starts and asks, hey, SPIRE agent, the first component of SPIRE, give me identity document. The SPIRE agent doesn't just blindly trust this workload. It performs a process, it performs a verification that actually verifies that indeed this workload is the one that it says it is, and it does that by communicating with the second component of the SPIRE, the so-called SPIRE server. This is the brain of the system. This is the control plane that actually holds the cryptographic key material to be able to sign identity documents and verify them, and it also contains additional metadata and information, which are the agents that belong to this server and which are the workloads that actually needs to communicate or can communicate with this agent. And if we need to map that to a popular runtime like Kubernetes, typically our pods run, our workloads run as pods. The SPIRE agent run as a daemon set on every single node or VM of our cluster, and the SPIRE server can run in the same cluster or can be collocated in a different one for cost reasons, for operational reasons, depending on how you want to run that. Okay, so far, so good. We saw a bunch of boxes, lines, and things, but we didn't actually see how the magic happens. Well, we will need one last term from SPIFFE and SPIRE so we can answer that. And this term is called attestation. You remember that I mentioned the agent and also the server do a verification, then do certain assertions to actually know and just don't trust, but verify that the workload is the one that it says it is. And this, in the SPIFFE and SPIRE terms, is called attestation. And the first level that the attestation happens is the so-called node attestation. It happens between the SPIRE agent, the one component of SPIRE, and the SPIRE server. For the purposes of the example, we will use GCP as infrastructure provider to illustrate how it works with it. But SPIRE provides a pluggable mechanism, so here you can plug AWS, you can plug a bare metal, you can plug even your own custom implementation without any sort of challenges. Okay, the whole process starts with step number 1. So this is the agent starting and obtaining the instance identity token from the internal GCP metadata API. This token actually is something that is uniquely issued by Google to every single virtual machine that they own and that they have running in their data centers. And the SPIRE agent sends that over TLS to the SPIRE server. That's the first and second step. Okay, the server doesn't trust, verifies, a common theme that you'll hear. The server checks that indeed this token is signed by the keys from Google. It verifies that cryptographically. In addition to that, it checks, okay, this is an agent running in a GCP project that I know. It also has a certain security group, maybe service account associated with the VM. And only if all the attestation parameters match, then the SPIRE server returns back in step number 4 a list of identity documents that the agent can use. Okay? That's the node attestation. The same pattern pretty much, but it's called the workload attestation. Happens again, but not between two virtual machines or two nodes running somewhere, but actually within the same physical host, between the process that is running in a given virtual machine or server and the server itself. The SPIRE agent, as you remember, runs on the host, and it runs with certain privileges. It knows, for example, how to communicate with the Linux kernel or the kubelet in case the pod is running in a Kubernetes as an environment. And whenever the workload starts, it basically sends an empty request to the agent and says, hey, agent, give me my identity. The agent makes a verification. It talks with the kubelet in the Kubernetes, verifies that a certain namespace, service account, and image are there. And if this attestation passes, on step number 3, we successfully have our precious credential 0, and then our workload can use it to communicate with other workloads, to communicate with databases, to communicate with whatever. And OK, without further ado, after this theory, Radu will give us an example of how it can work in practice.
Thank you, Jerome. For the architecture, of course, and also for the technical details. I'll try to break it down a little bit for all of you. And for that, I've picked my favorite use case, which is one that I guess everyone here at a certain point in time has had to deal with. This is a service-to-service communication. And usually we do it over a mutual TLS if we would like to be secure. Stefan told us about JOT tokens and how to deal with client-server in the previous session, but here we will focus a bit more on how we can achieve the mutual TLS with the technology that we have. I will show you a simple example before that without this technology and try to draw a parallel to see what's the benefits. Let's assume we have two simple clusters. Kubernetes, we have two services A and B. For those that are not accustomed to mutual TLS and don't know how it works, basically we have to create a public-private key pair, then we go through a certificate signing request, and we interact with a so-called public key infrastructure to be able to generate the certificates themselves. Not all certificates are made equal. It's a bit complex topic, so I won't dive into it too much because there are a lot of solutions as a service, and you can do the path using a self-sign one, but it's a complex topic. The common part is that once you get the certificates, you need to provision those certificates to your software. Usually that means you will store these certificates somewhere in intermediate location. Maybe humans will be involved in the process. And in many cases, no one wants to do it manually. It's a tedious process and it's error-prone. Someone can leak stuff. And we also need to keep in mind the rotation part and the expiration of the certificate. So not rocket science, but again, there are things that we need to be careful of. Usually people will stick a bunch of Jenkins jobs somewhere or some other CI/CD tool to automate as much as possible as this process. For example, if we say we are using Kubernetes, the one thing that I will do immediately if I have a very simple setup is I'm going to use GitHub and Vault. I will gonna follow the standard GitOps process and have all my application definition and service definition as code. I would like to store it in GitHub and also have some system like Argo CD, for example, that monitors the changes for these repositories and applies the lifecycle management operations like redeployments, configuration changes, and so on to the cluster itself. And ideally, I would like Argo to go pick the secrets that I need, whether they are credentials, where there are certificates, whatever, doesn't matter, to pick them up, create here the manifests and deploy the service. This is nice, but unfortunately it has few drawbacks, and this is mainly the fact that we are tying the lifecycle management of a credential with the lifecycle of the service itself. So we always have to go to our delivery pipeline basically to change our credentials. Then we will also need to do some magic here in order to change the credentials accordingly, to regenerate the certificate and put them. There are some plugins for Vault that can help out here, but it's a tedious process and we need to take care about it. Also, from security standpoint, it's not ideal because certificates are stored in a multiple location. We have it in Vault, which is secure, but what about our CI/CD system? Who has access to it and what happens there? And also to the cluster, but either way, we need to be there. If we adopt SPIRE, for example, the landscape of our two services in our example will look like, I have oversimplified here, of course, because a lot of stuff to deploy, but basically we have a SPIRE server. In each cluster, we have the dedicated agent that Georgi mentioned. They are deployed there without credentials, and they are being attested through the node attestation process here. The server has called the underlying Kubernetes cluster, maybe the GCP APIs like metadata service, for AWS, the corresponding thing, and has figured out that basically these SPIRE agents are okay and they're verified. For my two services to be able to communicate, I need to go to the SPIRE server and say, I would like to define the metadata for two services that need identity. I will define them, for example, with a GCP account that they're going to run in, with details about the Kubernetes cluster, maybe VM labels and stuff like that, security groups. Also, I will say, for example, the service account, the namespace, the pod image, maybe the SHA checksum of the image that actually represents the service and it's going to run. And then, in runtime, when the solution is deployed, basically, service A can reach out to the SPIRE agent, as well as service B, and it will go through the process of attestation. They will be verified, and they will be given a digital document. Fortunately for us, this document is actually X509 certificate, so we can basically directly use it to establish the mutual TOS connection. So let me try to mention a little bit more about how we adopt this, because the service needs to communicate with the SPIRE agent API. Usually we have two options. One, on the right-hand side here, would be to go the native way. The agent has gRPC API, so you can generate a client and you can put it inside your application or service. And this will be a very efficient way to deal with it. And on the other hand side, if you're lazy like I usually do, you end up with employing a sidecar. Basically, a proxy is deployed next to the service. And also this proxy, for example, when it's Envoy, it has direct native communication with the SPIRE agent. It can facilitate the fetching of the identities for the appropriate pod, and also can do the rotation. You can configure the Envoy proxy to do TOS origination and TOS termination. So basically, both services will have totally transparent communication. They will be unaware that their traffic is routed through a mutual TOS connection, which is a cool approach, more or less, but it has its drawbacks because it consumes more resources, adds additional latency to the system. It depends on the use case. So if we have to draw the parallel and think what we have gained by adding SPIRE, first, it's on the security side. We have moved from credentials which are which are stored in multiple locations and then are deployed through a deployment pipeline, to a solution where credentials are being injected in runtime. There are no third-party systems involved. There are no secrets need to bootstrap this communication. Credentials, like the X509, is stored in memory. Here we have the flexibility of having these certificates automatically rotated by SPIRE. And then we can move from something like very long-lived certificates like we usually have in our standard setups when we use Jenkins and we have to facilitate everything ourselves, to environment where we can rotate certificates every few minutes, 10 minutes, 15 minutes, and so on. Yeah, and with that, I think I've bombarded you with a lot of technologies so far, but there are a few things that I would like you to remember for this from this talk and take it with you. First, security is a journey. Check out the Zero Trust architecture. There's a nice paper in the public internet. You need to start thinking about security in a holistic manner. It's not about your application being secure and having all the CVSS ratings scores under 7.5 or something like that. We need to think about the processes, whether humans are actually interacting and how they're interacting with our solution. Secondly, don't reinvent the wheel. This is what we all do occasionally, but there are industry standards and tools and processes that are emerging out there. For example, SPIFFE and SPIRE. Georgi and I, we have been playing with them and exploring the capabilities of the software for the past year, trying to bring into the SAP's business technology platform to power a little bit the lower foundational layers. So from experience, we can say that the community is growing there, and also it is mature enough to be used in production environments. The applications of this technology is not only limited to stuff like mutual TLS and having JOT tokens. You can build on top authorization concepts, and you can also exchange these tokens with, and documents with external systems in order to get credentials, to interact with maybe cloud provider APIs and get tokens from that, or which gives tremendous flexibility. So check it out and play with it a little bit. If you're wondering, is it for you? We have seen that we have not created complexity. We could actually introduce more complexity. This is the reality of a distributed software. If you have a few services, then it will be totally overkill for you. If you have, like in your company, a team dedicated that deals with infrastructure and produces tooling that other people use in order to focus on developing applications, then you can definitely introduce this technology, and we will see TCO improvement and also making the whole process secure. And with that, yeah, I would like to thank you for your attention. I know yeah, if you have questions, now is a good time.
Or you can find us in the speaker's corner or around the hall. So,
questions? Okay.
Thank you for the presentation. So if I understand correctly, you've been playing around for a year. You're saying that the technology is ready for production. And how do you expect maybe the migration journey to look like from existing solutions to these problems, maybe like sealed secrets or HashiCorp Vault? Like, how do we not create a more complex system and some security problems on the way to this perfect solution?
It is not a bullet, silver bullet that will solve all your problems. You mentioned sealed secrets. It happens that we are actually using sealed secrets in order to deal with this type of issues in our deployment of SPIRE, because we want to avoid the chicken and egg problem, basically. But to address your concerns, I think it will be like gradual migration. I don't expect people to go change their coding. It depends on the use case. We will try to put it out there, potentially. Provide some guidance, like if you have older applications, try out, for example, the sidecar approach. If you're building something new, maybe consider it. Maybe run tests, try it out. co-deploy it and see how it goes, like on your staging, and maybe if you have non-production but test systems where you have enough load to get a figure of how significant the impact will be. Yeah, it's a good place to evaluate, but we're also struggling with that.
And just to add a few cents, so you know SAP also over the years accumulated some software. So it's hard, definitely step by step, start small, start with some maybe new applications that are developed, learn, incorporate the feedback. The approach with the proxy, with the sidecar and meshes, as they are de facto applying the pattern of the sidecar with a control plane on top. They are also a good way to actually decouple from the business logic, and in case, let's say, you can't touch certain application, you can still intercept the traffic and make the communication secure. So there are ways, but yeah, just need to start somewhere. Otherwise, just, it's hard, it's a mess.
Thank you for your presentation. What are the disadvantages? I think you briefly mentioned it, but with every system, there are advantages and disadvantages.
Maybe I can start this time.
Okay.
So, as Rado mentioned, I mean, complexity is not gone. It's just shifted, and you start thinking about it in a more structured way. And as every new thing and innovation, it takes time until things are settled. So, first challenge is how you run this SPIRE server, how you ensure that it's secured, how you ensure that it's protected, because it starts to be a fundamental thing that if someone compromises, then basically everything is game over. So yeah, that's one aspect of it. Yeah, I guess that would be at least for me.
Yeah, on a high level, these are the major concerns. On a very low technology level, when you start actually deploying it, the software is relatively simple to automate and deploy. It's not like you're running Istio, for example, where you cry. But still, there are some quirks. It has a plugin architecture that you can build your stuff inside, but there always may be something missing. We've heard previously a speaker talking about the pave road of pave path. If you are there, SPIFFE and SPIRE seem to be okay, but if you start dealing with very complex heterogeneous systems where you don't have only Cloud Foundry or, for example, Kubernetes, but you add stuff on premise, then challenges start to arise.
Yeah, that's a great question. So the question was concerns with availability. Yes, and fundamentally SPIFFE and SPIRE also kind of thought about that. One way of handling it is the SPIRE agent has a local cache, so it doesn't every time the workload starts goes to the server, so it creates a synchronous dependency. But actually, whenever an agent starts, it pre-caches the workload certificate, so it can serve them between the same machine. Yes. To a certain degree, that's true. Also, the validity, as you saw, I mean, you have a certificate typically valid for 5-7 days, so you have a tolerance of the server being unavailable for some time until the certificate expires. Of course, this affects if you roll out a new deployment and you now need to start all the workloads because you patch something and then the server is down. Yeah, your pipeline might be a bit affected with that, but the SPIRE server on its own, it also scales horizontally. So you can scale it, you can distribute it, you can have a good persistency. So you can take care about it of being important, and also split it or separate it around the world to actually limit in case GCP is down, to have one deployed on Azure if you want to be a cloud.
Yeah, it supports some kind of a hierarchy of deployments, basically where you can leverage the intermediate certificates. So basically you can have dedicated SPIRE server for each region and tolerate failures.
Okay, thank you.
Thank you too.